One, two, three. What is this mechanical activity that I am trying to do? This is nothing. This is just to introduce on the video. That's all. This is not called mechanics. Of course, this might also be called as mechanics, but in this video of Tour de Presidency, we have a special lab to cover, and that is our mechanical labs that will be covered in this Tour de Presidency's video. And for that, we have a lot of good people, of course, who would have done a lot of other mechanical works also, but not like me, of course. So we have Assistant Professor Mr. Prashant here. Prashant ಅವರೇ ನಮಸ್ಕಾರ. ನಾನು ಮಾಡಿದ್ದು ಮೆಕ್ಯಾನಿಕ್ಗೂ ಅದಕ್ಕೂ ಸಂಬಂಧ ಇಲ್ಲ
ಹೌದು, ಖಂಡಿತ ಸಂಬಂಧನೇ ಇಲ್ಲ.
That is what it is. So whatever I did was just for the video. But Prashant ಅವರೇ, how many years you've been here in the university? ಎಷ್ಟು ವರ್ಷ ಆಯಿತು? And also please just mention the number of labs, and then we will go inside the labs.
I'm here from past 6 years onwards. Okay. So there are a number of mechanical labs here, like machine shop lab, fluid mechanics and machinery lab, mechatronics lab, and then forging and forgery lab. Apart from this, workshop lab, which is a very basic lab. Okay. So and we have computer modeling labs also here. Okay. Right now in this is E block, and in this block we have the fluid mechanics and machinery lab.
Okay. So totally mechanical department has how many labs?
Totally mechanical department has around 8 labs.
Wow, fantastic. So the whole university has around 8 labs, and so now we will just keep walking. Yes. And we will also make sure that we cover every lab on the way that we walk. Yes. So what is that first lab that we'll be going to, Prashant?
So this now we'll be going to fluid mechanics and machinery lab. Okay. So in fluid mechanics lab we have different equipments. Okay. which is used for explaining about principles of Bernoulli's, the principles of rotometer. Right. How does the flow of water or the fluid in a pipe occurs, right, and what are the losses are occurring in the pipes. So these are all the things which we'll be discussing about.
Fantastic. So we will also get into the lab which is fluid mechanics and machines lab, and also Mr. Prashant. So just before we even enter this wonderful lab, can I at least know only in this lab, yeah, okay, the worth of the equipments that we have?
This is almost around 20 lakhs worth. More than 20 lakhs worth equipments are there here. Okay. And in this lab especially we have the wind tunnel.
Yes, that is the biggest superstar that we have, and I'll tell you why I call it the biggest superstar also, and we will talk about that as we go along. ಯಾವಾಗಲೂ ಹೀರೋ ಸ್ವಲ್ಪ ಲೇಟಾಗಿ ಎಂಟ್ರಿ ತಗೊಳ್ಳಿ. ಸೊ ವಿಂಡ್ ಟನಲ್ನ ಸ್ವಲ್ಪ ಲೇಟ್ ಎಂಟ್ರಿ ಕೊಡೋಣ. ಅದಕ್ಕೆ ಮುಂಚೆ we will see all the other equipments that we have. So what is the first thing that we'll be seeing?
So this is the centrifugal pump, which is part of the fluid machinery. Okay. And the centrifugal pump is especially used for checking the performance of the the pump. Whenever there is water flowing across the pump, right, so we have to check its volumetric efficiency and brake specific fuel. The other efficiencies, total efficiencies. All these efficiency will be checking in the centrifugal pump.
Fantastic. And on the lines of students utilizing this, yeah, so what is the life cycle process that they'll be doing it? ಅಂದರೆ ನಾನು ಹೇಳೋದು, ಈಗ ಇಲ್ಲಿ ಈ ಸೆಂಟ್ರಿಫ್ಯೂಗಲ್ ಪಂಪಲ್ಲಿ ಕಲ್ತ್ಕೊಂಡವರು, ವಾಟ್ ಇಸ್ ದಟ್ ಒನ್ ಥಿಂಗ್ ದಟ್ ದೇ ಕ್ಯಾನ್ ಇನ್ ರಿಯಲ್ ಲೈಫಲ್ಲಿ ಏನನ್ನು ಅಕಾಮಡೇಟ್ ಮಾಡಿಸ್ಕೋಬೋದು ಈ ಒಂದು ಎಕ್ವಿಪ್ಮೆಂಟಿಂದ ಅಂತ?
See, in centrifugal pump we have different parts, right, like strainer, okay, and especially mainly the pump. So if there is any for example, if the pump doesn't work, right, what is the problem with the pump? What is the capacity of the pump? They have to get to know about how the pump works. They have to get to know about, and for example, if mostly the pumps are used for the domestic purpose. Correct. So manali ega pump work agilla andre, what is the main problem with the pump? So those things and all will be teaching them. So if the pump doesn't work, what are the precautions to be taken? And if it works, for example, if you have different floors of houses, okay, for first floor, second floor, third floor, there are different heights. So which pump will be worth for which floor? Right. Is it worth for? So based on the capacity, the pump has to be procured. That is required.
Superb. So lovely, incorporation of the real life also with all these, and also we have reciprocating pump. Yeah. So what does this do, Prashant?
See, the reciprocating pump works similar to the engine. So in the engine, as we know, see there is a part called as piston. So piston reciprocates. Similarly, in the case of reciprocating pump, the main part is the piston. So because of the reciprocating action of the piston, the pressure is built. So this pressurized water can be pumped to a particular location for different heights or for different length. So it depends upon the, once again, the capacity of the reciprocating.
Definitely. And also instead of the domestic use, what importantly we are talking about is we are talking about irrigation as a big resource, because ಯಾಕೆಂದ್ರೆ agriculturally irrigation ತುಂಬಾ important ಆಗುತ್ತೆ, and these pumps gives so many I should be saying they give us food. Simple, they give us food, really.
Yes.
So now we'll be looking at Kaplan turbine.
Yeah, now Now this is the Kaplan turbine. Now the main function of a turbine is usually used to generate the power.
Correct.
So we have different types of hydraulic turbines. So under the hydraulic turbines, we have Francis turbine, Kaplan turbine, Pelton wheel turbine, and all. So this is the Kaplan turbine, which is a radial turbine. So the function of the Kaplan turbine is to generate the power. So now we have a storage tank over here. So from the storage tank, we pump the water, and the turbine generates the power.
Fantastic, right. So something like ಒಂದು ಚಿಕ್ಕ ಶಿವನ ಸಮುದ್ರದ್ದು ಒಂದು ಪ್ಲಾನ್ ಎತ್ಕೊಂಬಂದು ಇಲ್ಲಿ ಹಾಕಿದೀವಿ. ನಮ್ಮ ಡ್ಯಾಮಲ್ಲಿ ಏನಿದೆ ಆ ಥರದ್ದು
ಒಂದು ಪಾರ್ಟ್ ಇರಲಿದೆ.
ಸೊ ವಾಟರ್ ಸೋರ್ಸನ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಹೌ ಆರ್ ವಿ ಜನರೇಟಿಂಗ್ ಪವರ್ ಅನ್ನೋದನ್ನ ನಾವು ಕಪ್ಲಾನ್ ಟರ್ಬೈನಲ್ಲಿ ನೋಡ್ಬೋದು.
ಹೌದು.
ಫ್ಯಾಂಟಾಸ್ಟಿಕ್. ಸೊ ಇದು ಮಾತ್ರ ಎಷ್ಟು ಅಂದಾಜು ಎಷ್ಟು ದುಡ್ಡು ಆಗಬಹುದು ಅಂತ ಅನ್ಕೋತೀರಾ ನೀವು? ಲೈಕ್
ಇದು ಅದನ್ನ 8 lakhs ಅರೌಂಡ್ ಇರುತ್ತೆ.
So for all the installation and that's happening, so for all the students also to be using it, it's so nice to know where the power is coming in from, and also so with the wonderful setup here. ನಾವು ನೆಕ್ಸ್ಟ್ ಏನು ನೋಡ್ತಾ ಇದೀವಿ?
ಇದು ಬಂದು Pelton turbine. Okay. So this is an axial turbine. Okay. So this turbine generates power compared to the different specifications. Okay. So the power is generated. See, usually different types of turbines are there depending upon the source of water. So whether there is axial flow, if there is any radial flow of the water, or we are installing the turbine below the water level or above the water level, like that. For example, in case of tides. Correct. In case of tidal energy, we have to, if you want to generate the power, it should be an radial turbine. Right. So like that, this is one of the turbines.
Superb. And also we have Pelton wheel turbine also along. So this is the setup that we just got explained about, and it's fantastic to have all these things. And also we have turbine test rig. And why is that name?
That test rig consists of different parts. Right. See, we have to check various performance parameters. Right. For example, we have to check the pressure, we have to check the velocity, we have to check the flow of the water, so we have to check the volume. So that is why we call it as test rig. So if you see, the storage tank is there, but if you generally see in the water dams, we don't have the storage tank. Yes. The water will be continuously flowing in the dam, whereas in this case, since it is an experimental setup, we have a stagnant position of the water tank. That is why we call it as test rig.
Fantastic. And also one more name that person behind the camera, Pingal, ನಮ್ಮ ಫ್ರೆಂಡ್ ಅವ್ರು ಕೇಳ್ತಿರೋದು, ಅವ್ರು ಯಾರೋ ಫ್ರಾನ್ಸಿಸ್ ಅಂತ ಇದೆ, ಅವ್ರು ಯಾರು ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಸೊ ಬಿಕಾಸ್ ಫ್ರಾನ್ಸಿಸ್ ಇಸ್ ಅ ನೇಮ್ ದಟ್ ಇಸ್ ವೆರಿ ಕ್ಲೋಸ್ ಟು ಪಿಂಗಲ್, ಸೊ he is very fond of that name. So why is called Francis turbine? Was that the man who introduced it? Or
Francis is the name of the scientist who developed this turbine. That is why the name is Francis turbine.
Fantastic. So that we need to know. And also talking about the superhero. ಆ ಸೂಪರ್ ಹೀರೋ, ನಾನು ಏನಕ್ಕೆ ಅವ್ರನ್ನ ಸೂಪರ್ ಹೀರೋ ಅಂತ ಕರೆಯೋದು ಅಂದರೆ, ಐ ವಿಲ್ ಟೆಲ್ ಇಟ್ ಇನ್ ದ ವಿಡಿಯೋ ರೈಟ್ ನೌ, ಬಟ್ ರಿವೀಲಿಂಗ್ ದಟ್ ಸೂಪರ್ ಹೀರೋ ಕ್ಯಾನ್ ಬಿ ಡನ್ ಆಫ್ಟರ್ ಲುಕಿಂಗ್ ಅಟ್ ದಟ್ ಅದರ್ ಲ್ಯಾಬ್. The whole concept of Tordi Presidency, okay, that we are playing out on our YouTube channel of official Presidency University, the idea itself came from the superstar. Because you know what, Prashant, none of, like most of the people who are not connected with the Mech lab, okay, may it be anybody, okay, in our university, probably had no idea that we have a wind tunnel.
Yes.
So and this wind tunnel costs a lot.
Yes, wind tunnel costs a lot.
So only the cost of wind tunnel, can you just tell us?
It is around 13 lakh.
Exactly. So that's such a big wind tunnel, and I will be even proudly saying that as a private university, probably very rare universities have such things.
Yes, yes. Yeah. If you see around Bangalore, there are many colleges, and we are the maybe many of the colleges doesn't have the wind tunnel. We are the only one who have a wind tunnel over here. And if you see maybe only in NIT Surathkal or in IITs there will be wind tunnel, but in our university we have this wind tunnel that is great.
Absolutely great, because we are doing all this for our students that who will be joining Presidency University. That is more important. We will talk about the wind tunnel after covering that other lab, because he's a superstar. This wind tunnel is definitely a superstar. So we will talk about that, and we will show a lot of footage about the wind tunnel and how it runs and all that just after covering to that lab. So Prashant, we'll go to the other lab.
Yeah,
Sure.
sure.
So we are now in the fluid mechanics lab, and Prashant is also still along with us. So ಇಲ್ಲಿ ಏನು ನಡೆಯುತ್ತೆ ಪ್ರಶಾಂತ್ ಅವರೇ? ಇಲ್ಲಿ ಏನೇನಿದೆ equipments ನಮ್ಗೆ?
ಇಲ್ಲಿ ಕಂಪ್ಲೀಟ್ ಫ್ಲೋ ಮೆಜರ್ಮೆಂಟ್ ಡಿವೈಸಸ್ ಆ್ಯಂಡ್ ಎಕ್ವಿಪ್ಮೆಂಟ್ಸ್ ಇಲ್ಲಿದೆ. ಸೊ ಬೇರೆ ಲ್ಯಾಬ್ ನೋಡಿದ್ದು ಮಷಿನರಿ, ಫ್ಲೂಯಿಡ್ ಮಷಿನರಿ ಲ್ಯಾಬ್. ಈ ಲ್ಯಾಬ್ ಒಂದು ಫ್ಲೂಯಿಡ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ಲ್ಯಾಬ್.
So basically ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದರೆ it will probably be measuring something, the flow of the fluids or everything like that?
ಹೌದು, ಎಸ್. These devices which are there here is used for measuring the flow of water, velocity of water, and to measure the pressure of the water flowing in a pipe.
Okay. So can we go equipment wise, and can we please explain it out? What is this all about?
Now this is an equipment which is used for measuring the flow of water in a series of pipe. Now as the name is mentioned, series of pipe, the pipes are in seriously connected.
Right.
And this is also used for checking the losses of
Loss of water.
yes, losses of water.
Yes. That is more important. Yeah. Yes. Please tell me.
So here you can see these pipes are in series and parallel.
Yes.
Okay. So in series you can have like different valves are there. Through that you can change the direction. So it will become in series, and it will be parallel flow also. So you can calculate the pressure loss in there.
Alright, fantastic. Can I ask you on the video? Can I ask you, where's your close friend, Mr. Kuvar Singh?
The Kumar Singh he's taking the class.
Really?
Yeah, he's taking.
God, he's so busy a man, because he says that okay, in half an hour I will meet you, but that half an hour doesn't come at all. It becomes half a month.
No.
But yeah, joking.
Really, we are-
Jokes apart. But yeah, so fantastic. So yeah, so what will be the next equipment there?
So the next one is again the losses. We are going to find out the losses in the pipes, and this is called major losses.
Right.
So here in the pipes, when you are running any fluid, because of friction, there are losses. If you have like different material pipes, then there will be a different friction factor for it.
Correct.
So suppose you have a big pipeline
Right.
to supply of oil from somewhere. So that is made of like cast iron or steel,
Okay.
and the diameter will be there. So you need some pumping power for it.
Correct.
Suppose you are supplying from Bangalore to some other place. So nowadays, suppose IGL is there, that Indraprasth Gas Limited, or any other company who is supplying that gas through the pipes.
Correct.
So there are a lot of friction losses in the pipes. So here for the water, we can find out how much losses are there.
Right.
That is
So
called major losses.
okay. So according to you, what is the no? According to you, what is the best pipe suited to transfer water and gas? You need to differentiate, because we've always seen water is transferred through cement pipes and all that.
So it should be a smooth pipe where.
No, I want to know the material.
So the material, if you have like a steel pipe,
Okay.
so there you have a like less friction factor will be there.
Nice.
Okay, but the cost again you have to factor in it. So nowadays they are coming with a lot of poly different kind of plastics pipes.
Correct.
Okay, so you can reduce the cost, at the same time you will have the same efficiency.
Right. So you don't
Depend upon the utility also, how much pressure will be there. All these things you have to keep in mind when you are designing a pipeline for different things.
okay, which is more cost effective according to you? Because is it the cement pipes or the steel pipes? What do you feel is
It will be comparably, it will be having like less cost, because steel will be more.
Yes.
Then again, that is what we are delivering in workshop when we were doing that. Which kind of pipe you have to use for what purpose. So it depend upon utility, you have to select the pipes.
So still, according to you, so the steel pipes are the best for gas transformation. What is the best one?
Gas, they are using cast iron. Yeah.
Right. So what is this equipment? Yeah, please.
So this is about like we are going to find out the impact of jet wind.
Okay.
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 Impact of jet on wind.
Oh,
So you can see we have a, you can see nozzle is there. On that from there,
Yes.
the velocity will be high and it will impact on the wind.
Okay.
Okay. So what is the utility of this?
Uh-huh.
Suppose you are designing, in the last lab you have seen different turbines.
Yes.
So in turbine blades are there. On the blade, the water will come and strike on it.
Right.
Then it will rotate. So how much force is there, which which we are going to find out here.
Lovely.
Okay.
Lovely.
So
Right. And V-notch apparatus. What is
okay, this is generally notches are there. You can see. I think you have seen all these things in the dams and other places.
Okay.
Okay, so there again you can find out how much coefficient of discharge will be there for this,
Okay.
and the application of this is in like dams, canal, and other places.
Oh, okay.
Okay, so different types of this is only V. Other type of notches also we can.
Right. That is why it's called V-notch. Right. It's in the position of V. Right. Okay.
This is orifice and mouthpiece apparatus. Again, see these devices we are using in a flow measurement places.
Okay.
So we are again how much efficient that device is actually in terms of coefficient of discharge. We are going to use it, and directly when we are using here, suppose you bring some other apparatus, you can test here.
Right. So can we, because this is on the on button, can we like
show you something else where that will be much.
it can be functioning? Oh, fantastic. That is
This is also functioning.
right.
This is functioning. This is a venturimeter. Again, this is used for flow measurement.
Okay.
Okay, and the coefficient of discharge for this is around 0.9 to 9.5.
Okay.
Okay, and you can see you have here test section. You can see
Right.
this is convergent nozzle. Then it's here is your throat. Then divergent nozzle.
Lovely.
You have to pressure measuring device that is connected through this manometer. U2 manometer, so you can find out how much pressure difference is there. So these devices are generally used for flow measurement.
Lovely. So what is that apparatus that you will be running for us and showing it to us? So that's really
So
nice to see.
Manjekoda is not here.
Okay, no problem. So what is this now?
This is orifice. Again, we have three flow measuring devices. One is orifice, venturi, and rotometer.
Okay.
So these all three are again based on application we are going to use. This generally we use for air flow measurement.
Okay.
So we have another lab like ice engine or heat transfer where we are using this orifice meter to measure the flow rate, air flow rate.
Right.
Okay.
Lovely.
And this you see, this is in 1883 Osborne Reynolds. He came out with this apparatus. With that you can find out the flow is laminar or turbulent. Now see, in this case, water is there. So based on that, a number is there. It's called Reynolds number.
Okay.
For a pipe, we are performing one experiment. So if the Reynolds number is less than 2000, the flow is called laminar.
Okay. The flow is called?
Laminar.
Okay. What is that?
Laminar means the flow, all the you can say water particle flow in streamline. Okay, so the vectors are there that is parallel to each other. They are not mixing to each other. So it's like that. Suppose you have in a classroom, students are sitting. They are in a they are not mixing with each other. And if you see they are coming out from the classroom, and you have a camera there, the student will come and move in like zigzag path. They will mix each other. So that flow is called like a turbulent flow.
So that was Dr. Devendra telling us about the fluid measurement lab that is specialized there and worth a lot of money also, because the reason why we say the money involved is here because we need to signify on the fact that how much is Presidency University offering the students. And now we have Prashant also here. Prashant,
Yes.
superstar ಬಗ್ಗೆ ಮಾತಾಡೋಣ.
ಹೌದು ಮಾತಾಡೋಣ ಸೂಪರ್ ಸ್ಟಾರ್ ಬಗ್ಗೆ
ಖಂಡಿತ, yes. Wind tunnel again, it's here, and this is the reason why we started this Tordi Presidency series, so that whatever is inside should be known to the outside world. That is more important, and that is why we're doing these videos. And so can we take a tour of the wind tunnel, especially?
Yeah, please. See, if you take any wind turbine, there are aerofoil blades mounted on it. So whenever the wind passes onto the aerofoil blades, the wind is getting diverted. So if the wind is getting diverted, the speed is also reduced. So there is change in speed, and because of the change in speed, this will affect the blades of the wind turbine. Thus, we have to measure the lift force of the blade, drag force, pressurized force. So these forces, as well as the velocity of the flow of the wind. Now, it is not possible to check all these parameters directly onto the wind turbine. Before that, we have to optimize the wind turbine blades. That is why we have to utilize the wind tunnel. So this is the wind tunnel, which is
So how different it is from any other turbines that we generally use?
See, in this we use a stagnant model. Now these are the different types of models which are there, which are utilized in the wind tunnel. This is an aerofoil blade of different geometrical cross sections. This is the flat phased aerofoil, and we have multiple flat phased aerofoil devices over here, models of different cross sections. And this is the cylindrical model, and that one is the spherical model. So we have now
So we'll just go back to that cylindrical model.
cylindrical model.
That is cylindrical model. Yes.
Yeah, cylindrical model, and that one is the spherical model.
Spherical model, right? Fantastic. So it is all about any wind tunnel can be changed depending on these equipments, because there what we see there that is the portion.
The aerofoil. That is the aerofoil. Any cross section of a wind turbine blade is called as aerofoil. So based on the cross section of the aerofoil, we can optimize the wind turbine blade rotation.
So this aerofoil kind of becomes like a heart of our superstar, if I can say.
Yeah, this is the heart of our superstar. Yeah.
Lovely. So when the machine is on, and when we are experimenting it out and measuring out all the force that is coming out of the wind.
Yeah.
So what sort of role this actually plays?
See, now this wind tunnel has two openings. This is an open wind tunnel. At the inlet section, we pump the air at a constant speed. Now that constant speed of air is passed on to this aerofoil section. Now onto this aerofoil section, we have different portals, which is used for measuring the pressure. And as the air passes towards the end section at the exit port, it is considered as diffuser. So the function of the diffuser is to reduce the dynamic pressure of the air passed on to the aerofoil.
Right. So superb, Mr. Prashant. It was really nice to know the one section of mechanical department. I should be saying, it is just one part of it, and probably we'll be concluding on this video. We'll be also making sure we have another video, which will be a continuation of the mechanical department. But thank you so much for your time to explain this.
Thank you very much. Thank you for the patience with me, and thank you for the time provided for me.
Thank you so much. And you are more patient to tolerate me. Thank you. Keep watching more videos on our Presidency University YouTube channel, guys. Thank you, Prashant.